So this video will be an intro to functions, and functions are like one of those things where honestly you've seen them, but you probably just weren't told that this is a function. A lot of things that you work with in algebra are functions. So functions really just refer to a particular type of relationship. And so over this series, I'm going to kind of break that down. Okay, so the first thing we want to talk about, just what is a relation? So a relation is like a general term. So a relation is any set of ordered pairs. And with every relation, you have a domain and range, where the domain is the set of independent values that's usually like the x values, and then the range refers to the set of dependent values. So that's usually the y values. So all relations have this domain and range, and this becomes like a bigger deal the higher up you go in math. So domain and range gets used a lot like in higher math classes. Okay, now in some cases, like in this next example, the domain and range is actually pretty easy to pick out. So here's a set of ordered pairs, and remember, a set of ordered pairs, that is, right, any set of ordered pairs defines a relation. So the second I know that I have a set of ordered pairs like I do here, that's a relation. So now I'm asked to define the domain and range. Okay, so really the domain is usually going to be the first, like if you have an ordered pair like this, it's going to be the first coordinate, i.e. usually what we think of as the x coordinate. So the domain will be 2, 4, and 7. And then the range is just the second coordinate in these pairs, so the range will be 3, -1, and 2. Now, usually when we're talking about this, a lot of times, like when you're just talking about a set of numbers, you'll use set notation. So some homework systems, I think, can be a little picky about that, so just a heads up on that. Okay, so we have the general concept of a relation, and so now we can talk about what a function is. So a function is a special type of relation where each element of the domain corresponds to exactly one member of the range. And this is one of those times where this sounds like a really stuffy math definition, where it's kind of like, okay, what does that even mean? So I think this definition is actually a lot easier to visualize. So what I want to do here is I want to set up 3 sets of domains and ranges. And so it doesn't really matter, by the way, like a lot of times when we think about functions and relations, we think that we're talking about math. So we think we're just talking about numbers. So we don't actually care about what is in the domain and the range. So this could be like people. So this could be like people and their social security number. Or you could have like I'm just saying, it doesn't have to just be numbers, I guess. There are other types of situations that you can come up with where they have a relationship, like they come as a pair and they have a relationship. So like a person and their social security number is a really good example, or an item that you go to buy and its barcode, that would also be like a paired relationship. So I bring that up because these are just dots, and it's because I don't care what's in the domain and the range. Maybe it's numbers, maybe it's people, whatever. The thing that I care about is how these elements in here, whatever they may be, map to these elements in here. And there's 3 different ways that this can happen. So in the first way, so I want you to take a look at how this mapping works. So I've mapped each member of the domain to something in the relation. And this defines a function. Also, so if we go to this next pair, this type of mapping is also a function. So I want to point out what's happening here. Each member of the domain goes to exactly one member of the range. So it's fine, like in this example where I'm telling you this is a function, it's fine if 2 different members of the domain go to 2 different, or go to the same thing in the range, that's fine. But let me show you what's not okay. This is exactly what's not okay and would not be a function. So this member of the domain goes to 2 separate things in the range. So this is the one like type of relationship that we can't have, and so that's what we have to watch out for. So And again, so it's this little part right here, that's the problem. Okay, so going back to our ordered pairs from earlier, this 2, 3, 4, -1, and 7, 2, is this a function? So if you just have like a nice set of ordered pairs like we do here, you can honestly like create your own mapping. So here's my little mapping. 2 goes to 3, 4 goes to -1, 7 goes to 2. So yeah, if we come back to this idea, right, each member of the domain goes to one thing in the range, this would be, yes, this is a function. Okay, so why don't you take a look at this one, and why don't you just set up your own mapping for a second and decide if this is a domain, or sorry, decide if this is a function. Okay, so in the domain, I have 4, 3, and 7, and in the range, I have -1, 2. I have -1 again. I don't have to repeat that in the range. Okay, so 4 goes to -1, 3 goes to 2, and 7 goes to -1. So if I go back to that visual representation, right, two things in the domain can go to the same thing in the range. That's okay. So the fact that 4 and 7 both go to -1 is fine. So yes, this is still a function. Okay, and let's just try one more example here. So same idea, hit pause and then hit play when you're ready. So this time in the domain, we've got 2 and 3, and then we've got 4, 5, and -1. So 2 goes to 4, 3 goes to 5, and 2 goes to -1. So once again, this is the problem spot. So no, this is not a function. So this is like pretty easy to figure out if you have just like a set of points. But like the reality is most of the time functions have to do with equations. So when we're talking about equations, we have a special notation to denote that we are working with a function. And that notation looks like this. It's this f with these parentheses and this x. And what we say is we say f of x. So you want to make sure that you're using that notation properly. So whenever I read this, I always say f of x. And by the way, you don't have to just use f and x. You can use other letters. So this would be g of x, h of x, a of m, z of k. So normally what happens is like, so maybe you're thinking like, well, how do I know that I'm not supposed to multiply these together? You will always be told, you know, that g of x is a function, a of m is a function. And so when you are told that, then you get for free, like what that means is that it fulfills this definition, or another way to think of it is you are guaranteed if you're told that it's a function that it's going to have one of these types of okay relationships. So this notation is kind of important because it denotes something. And like I said, like when you first learn it, you're like, okay, whatever. But just like it's kind of one of these foundational things in math that as you kind of move through different courses, depending on how you go, nicer things happen with functions. So they are just like nicer entities to work with. Now, how do you actually use this notation? So if you have like a set of ordered pairs, so going back to that same set we keep playing with, like this actually is telling you your inputs and your outputs. So the way that this works, so what is f of 4? If this is my function, which we know it is a function, so you input an independent value, in this case 4, and the output is the dependent value. So in this case, I just need to refer to my ordered pair. And so my f of 4 in this case is just given to me. It's equal to -1. So when you have ordered pairs, this is actually like not even something you have to do any work for. It's like the answer is right in front of you as long as you know how to read the function notation. But how this gets used more likely in math is, you know, like I said, so we have f of x, g of x. These denote usually like equations. So it's still the same idea, though, of an input and an output. So one of the nice things about functions is that also it makes it clear which equation you're referring to. So if I say, what is f of 2? I am referring to this equation. If I say, what is g of 1? I am referring to this equation. So there's like no guessing or you're not sure. You know exactly what I'm talking about. And so the whole idea behind this is, so here's my general idea. And then if I put something in here for x, that's what I want to put into the equation. So when I say, what is f of 2? That means replace x with 2. And then you just work it out from there. So this becomes 4 plus 1, so this is going to equal 5. So maybe you could just take a second and calculate g of 1 just to make sure that you've got this, and then hit play when you're ready. So I've got 1 squared minus 3. So that's just going to be 1 minus 3, so this is going to equal negative 2. Okay, now, one of the really strong things with functions is that they also let us do some more theoretical calculations. And again, this like serves as like the foundation of like what's to come. So theoretical calculations would be something like, what is f of a? And you really want to keep in mind that the whole idea behind this is, what does this mean? This means where I see an x, replace every x with whatever I input here. So what does that mean then if I say, what is f of a? That means literally replace the x with an a. So let's do that. So if I do that, there's not a lot I can do in this case, right? This just becomes 2a plus 1, and that's all we can really do. And that's totally fine. So when we get with like more theoretical calculations, usually there's like some other meaning with this. So right now we just want to get used to like playing around with this, and then, you know, sometime in the future you will probably see this come back again, and you can make other interpretations with it. Okay, so I'm not going to lie to you, this g of h plus k, this one is actually a little harder. So what I would love for you to do is I would actually love for you to set this up and then hit play. So let's just check your understanding and then hit play. Okay, so you really have to calm your mind when you think about this, because I find that a lot of times people's minds kind of go wild with what does this mean? And you want to repeat to yourself, if you find that your mind is going wild, just repeat to yourself, anywhere where I see an x, replace it with whatever is inside of here. So now where I see an x, I'm going to replace all of x with an h plus k. So here's how that's going to look. Okay, so pat yourself on the back if you got that. And if you didn't get that, then, you know, it's all good. Hopefully you learned something. And now finish this problem. So simplify it as much as you possibly can, and then hit play when you're ready. Okay, so in this case, I need to FOIL this out, right? This is h plus k times h plus k. So I have h plus k times h plus k minus 3. So this becomes h squared plus 2hk plus k squared minus 3. Okay, and this is all I can do. I have no like terms, so I can't go any farther with this. And I think, like, again, like your brain might try to mess with you a little bit on this, but like this is what we were asked to do, is evaluate this function with h plus k. We're not being asked to solve anything. We're not being asked to do anything else. When we're asked to find the value of a function, this is all we're really asked to do, so we're good to go. Okay, now, since we are talking about equations, sometimes with equations, you know, like if I just give you a general equation and I ask you, is this a function? That can turn into kind of a tricky exercise. But if you know the graph of what a particular equation looks like, or relation looks like, you can pretty easily figure out if it's a function with the vertical line test. So the vertical line test is, it says this. So a graph represents a function if any vertical line drawn on the graph never intersects the graph more than once. So let's talk about what does this actually mean in an example. Okay, so I have a graph here and I just want to know, does this represent a function? And I graphed this off of Desmos.com. Okay, so what the vertical line test is getting at is, so if I start drawing vertical lines like I am here, if the vertical line intersects the graph more than once, then it's not a function. So see how I'm intersecting at 2 points for each vertical line? That means that this graph does not represent a function. So the vertical line test is actually like a pretty easy thing to use, like once you understand what it says. So maybe pause here for a second and look at this second one. So does this graph represent a function? So yes, this one definitely does. If I draw all these vertical lines, they're only going to intersect once. So yes, this is a function. Okay, so that's kind of your intro to some of the basic things with functions. If you found that helpful, I would love it if you liked the video or subscribe to the channel. And we'll explore a little bit more with functions as we go along in this series. So I will talk to you guys in another video. Thanks for watching.